Alright guys, welcome back. We're going to be solving another question from the second chapter of the Engineering Mechanics Statics by Meriam. We have question 85. So for the truss loaded as shown, we need to determine the equation for the line of action of the standalone resultant R and state the coordinates of the points on the X and Y axis through which the line of action passes. So basically we have all these forces and we can see X and Y in this question, and an origin is at point A. So we need to replace with all of these forces and the moments that we have from these forces with only one single force that represents the resultant of all of these, and also it's going to make the same moment in this system. So basically we're just going to find the resultant and that moment about the origin first, and we're going to see if the moment is clockwise or counterclockwise, and we're going to go from there. So let's just go with the resultant. As we talked about, oh, there's a note at the end of the questions are that says all triangles are 3, 4, 5, and what that means is when we have right triangle 3, 4, 5, which means one side is 4, 5, and the hypotenuse is 5, and that's going to help us to find the horizontal and vertical components. I'm going to explain later. So our R would be sum of all forces, and obviously it's going to have X component and Y component. Let's see what we have in X direction. So we have the 40 kilonewton, which is positive. Again, this is our positive X, and this is our positive Y. So 40 plus 20, so 60 kilonewton positive to the right, and we have the X component of this force. If we resolve it into X and Y, we can see that first of all it's negative, so negative 35, and we have to find the horizontal component, and for finding this angle is going to be same as this angle right here, because these two are perpendicular, and we can see that the force is also perpendicular to the that member of the truss. So, and we know these right triangles that we have in here are all 3, 4, 5. So what we need in here is the cosine of alpha for finding the horizontal component. Cosine of alpha we can see is in this right triangle is 3 over 5. So times 3 over 5, that's everything for X component. The rest of them are in Y direction. So let's go on, let's just clean up the figure and see what we have in Y direction. So for Y, we're gonna have the 15 kilonewton, so negative 15, and oh sorry, positive, because this is our Y positive direction, and also we have the Y component of 35, so plus 35, again downward positive, times this time will be sine of alpha, so 4 over 5, and that's going to be our J. So that's our resultant. Let's see what we get. So 60 negative 35 times 3 over 5 is 0.6. So our R would be 45i, and also 15 plus 35 times 0.8, 4 over 5, 15 plus 35.43J. Did I make a mistake in the previous one? 60 minus 35 times 0.6. Yeah, that's going to be 39. I probably missed the negative sign in the previous one. So 39.43, and yeah, the unit's going to be in kilonewton. So that's our R. We can see that both I and J components positive, which means our R is, if consider this our X and Y, it's going to be in this direction. All right, so now let's find the moment about A. And what we're trying to do at the end of this is basically we are trying to replace all these with one single R. So far we know that our R is in this direction, so the line of action is in this, but the only thing that we don't know for now is that if the moment is clockwise or counterclockwise, because if the moment is clockwise, it has to be in this direction in order to make a clockwise moment, and if it's below the x-axis, it's going to make counterclockwise. So that's the next step that we need to figure out, and we're going to figure it out based on the moment about A. So let's see what we have. We have the moment of the 40 kilonewton about 8. That's counterclockwise. So positive 40 times the distance is 6. We have this 125 kilonewton meter. That's clockwise. So negative. Forgot to show the sign convention that we have. We have counterclockwise positive as our sign convention. So negative 125, we have the moment of 20 kilonewton. That one's also counterclockwise, so positive 20 times the, so r times distance, and the distance would be the distance from here to here, which is going to be because all the triangles are the same, they're all 3 4 5, so they have the same distance. So if this is 6, this will be 6, this will be 6 too. One thing I forgot to mention though, so if you just multiply these by 2, it's going to be the same ratio for each of these triangles. So it's 6, 8, 10. But the ratio is the same for finding sine and cosine is 3, 4, 5. So it's the same thing, but you have to watch for the distance in here. So 6 times 3. So this one's out, this one's out, this one's 2. And the 15 one is not going to make any moment about A because it passes through that point. But we're going to have the moment of 35 again. It has 2 components. Let's go with the horizontal one. We can see that the horizontal is counterclockwise, so plus 35. It's the x component, or what we found in here, times 3 over 5. So that's the force, and the distance would be, we're going to have another 6 in here, so 6 times 4. And we have the moment of the vertical component. This one, as we can see, is clockwise, so negative 35 times the distance is going to be the vertical distance from A to the line of action. This is the line of action, so 8. And yeah, I think that's pretty much everything. We consider all of them. Let's see what we get for this one. So one thing I missed in here is the 35. I forgot to multiply the sine of alpha, so 4 over 5, and the distance is going to be, yeah, the distance that we have in here would be the 8. So let's see what we get. In here, I made a couple of mistakes here, so they are all negative, and I forgot the 4.5, and this is going to be 8. Let's see what we get. So 40 times 6, negative 125, plus 20 times 18, negative 35 times 24 times 0.6, negative 35 times 0.8 times 8. That's going to be negative 253 kilonewton meter, and the negative sign shows that the moment is clockwise. So what's gonna show us, this is gonna show us that the moment about A has to be clockwise, so the correct position for R is above x-axis, so this is gonna make a clockwise moment, so this one's not correct. And the last step, we just have to find the line of action of R, or the equation for the line of action. So for doing that, now that we have the moment, which is 250, we know moment about A is R cross F. R is position vector, and moment is will be found in here, and this is going to be in Z direction. And for R, let's just do I, J, K, the determinant that we have for our matrix. I'm going to call it X, Y, 0. And in the last row, we're going to have our force, which is what we found for our R, 3943. So 3943, 0. and this has to be equal to the moment that we found, 253. So let's see what we get for doing the determinant. Obviously we only have, there's no x, there's no y, and it's going to be in k direction. So 43x plus negative 39y is equal to 253, and that's going to be our equation. And for finding the x and y intercept, so if our x is 0, we're going to find the y-intercept, 253 divided by 39. So 253 divided by 39, it's going to be 6.49 meter. All the distances are in meter. Yeah. And for y-intercept, x-intercept, so we're going to put y0, and we're going to have 253 divided by 43. Yeah, that's going to be 5.88 meter. And just to check everything one more time, I missed the y negative sign in here. So we are expecting to get a negative y value and a positive x value. So just to double check if you got confused about the signs or made mistakes. So negative for y, positive for x. And yeah, that's pretty much everything for this question. Hope everything was clear. And let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.